Complex numbers. Complex numbers were created to solve the problem of finding the square root of a negative number. Since there is no real solution for this situation, we needed to create a way to deal with it. We solved this by using the following definition to define the square root of a negative 1. Definition: I equals the square root of a negative 1. Using I when we confront the square root of a negative number is a way to deal with this formally undefined concept. It is very important to have this solution available. Properties of imaginary numbers. Since I is equal to the square root of a negative 1, then we have to decide what does I squared equal to. Well, when we square a square root, it gets rid of it, so that should be a negative 1. I cubed would be I times I squared, so that would have to be a negative I. And then I to the fourth equals 1. And you could see this by squaring I squared. You'd get negative 1 times a negative 1, so you're going to get 1. And then I to the fifth is really I to the fourth times I, so that'll be I. I to the sixth is really I squared times I to the fourth, so that's got to be a negative 1, and so on. If you just continually break them down into the smaller ones, that's once we know what I squared, I cubed, and I to the fourth is, we can get all the rest of them. The table shows that all powers of I reduce to either I, negative 1, negative I, or 1. Therefore, your answer should contain no powers of I. Example 1. Simplify I to the 17th. I to the 17th is made up of I to the fourth times 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 I. But since I to the fourth is 1, it'd be 1 times 1 times 1 times 1 times I, so we're going to get I. Example 2. Multiply these two binomials. They both have radicals. Inside the radicals are negatives, so therefore we do have an imaginary or complex numbers. Now before we can do anything with an imaginary or complex number, we need to change it into I form. That was the beauty of changing something to I, because if we leave them as negatives, things don't go right for us, so we've got to change them into the I form. So we rewrite it. We pull the negative out as an I in both cases. So now we have I square root of 2 plus 3 times I square root of 18 minus 5. Now we can treat I, it follows all of our rules, that as if it was a variable, say x. So just think of it as x, and then when you get all done, simplify it according to the little chart on your left there. So we go I times the square root of 2 times I times the square root of 18. We get I squared square root of 36. Then distributing the I square root of 2 times a negative 5, we get a negative 5I times the square root of 2. Now distributing the 3 times I to the square root of 18, we get 3I times the square root of 18. And then the plus 3 times a negative 5 is a negative 15. Okay, you change the I squared according to the table is a negative 1, so it's going to be a negative. And the square root of 36 is 6, so we get a negative 6. Minus 5I squared root of 2 plus, now the square root of 18, which we wrote as 9 times 2, you can bring the 9 out as a 3. So then that would be 9I times the square root of 2 minus 15. Then we collect our like terms, a negative 6 minus 15 is a negative 21, and a minus 5I plus 9I would be a plus 4I.